Okay, so I mean this is recording now. Okay, so the way that we want to so we're gonna construct these AI enemies, and the way that we're gonna do it is kind of like what we discussed in class last Tuesday. So on Tuesday we talked about this idea of state machines. So the idea of a state machine is that each state represents a particular behavior your characters or your AI characters are going to carry out, and then it's going to check to see if it's possible to transition or if it needs to transition to the next state. So I've drafted a state machine that we're going to follow for our character. So in this case, we have this black dot represents kind of the initial or start. So once it starts, the game starts, the character enters into this wander state. And so we're going to have some wander behavior for the character, which in this case, the character's just going to move back and forth randomly at a kind of set a pace that you dictate. So from wander, it'll get out of the wander state once it can see the enemy. And so we're going to define C in this case is how far the enemy is from the player. And so if the player's within range, so we can see the player, and that it'll move into this kind of pursue state. And so pursue, what it's doing here is now it's going to chase after the player. And so in this case, once in the pursue state, it'll then determine if it can attack if we have if it's within its cooldown period. So so for like some AI characters, in order to keep them from just kind of being fixated on attacking, you'll introduce a or it really is being fixated on a particular behavior, you can introduce a cooldown, which in that case, what it does is that you'll execute a behavior and then kind of set a little timeout before you can do that behavior again. So from pursue, if we're within the cooldown period, the cooldown period is expired, we're going to attack. We'll do the attack and then immediately go back into the wander state. And so in this case, if the enemy can still see and attack the player, it'll still kind of advance back to the attack. So first go into wander, it'll play the wander, see the enemy, go to pursue, and then until the cooldown is met, it'll just keep doing pursue, and then once the cooldown is expired, it'll go back into the attack. And likewise too with the pursue, it'll get out of pursue if we can no longer see the enemy. And so in this case, if we can't see the enemy, just go back to the water stream. So this encompasses all the different behaviors that we want our enemy AI to do, and we've defined kind of different transitions to make that happen. So in Unity, kind of what I mentioned in the last class is that what we can do is take the character control. So if you remember, for our main character, we have this character controller script. And so this is the script that's responsible for moving the player character around space. And the way that we're moving the character is that we're just listening for inputs that a player provides. So if they're pressing the arrow, then we're moving from side to side. They press space or the W button, then they do a jump. So all that's being handled by the character controller. And so what we can do is we can extend the character controller. So we can this goes back to the ideas of object-oriented programming, where we can kind of make a new class that's derived from another one. So we're going to make an AI controller class that derives this character controller. And so what we can do with that is instead of listening for the inputs from the player, we can now implement this state machine that we've designed that does not handle the AI. So in that the assignment 6 package I provided, it has an AI controller script. And so I'm going to go ahead and open that up so y'all can see what's included within this script. Okay. So in order to do the state machine, what I've created, we don't think we've talked about enumeration types, but an enumeration you can think of as just kind of, it ends up being just a set of integers, but you give them kind of, you give them names associated with it. So in this case, so we have a wander behavior, a pursuit behavior, and attack behavior. And so the enumeration then, it's really just it's a different way to kind of specify a set of a range of variable types, or kind of a range of variable values that you have for a particular variable. So in this case, because our behavior there can only be 3 values for our behavior, we define them as wander, pursuit, and attack. And so we can track what the behavior state is. And so we're just saying, so the variable type here is our behavior enumeration. And then we have some private variables to track the movement of the AI character. So, what was the last time the AI character switched its direction? So that's where this next move comes into play. This next attack, that serves as the cooldown. So, so tracking to see how long that cooldown period, or when's the next time the AI character can attack. And then tracking just kind of which way the character's moving at any given point. And then we get into the public variables. So this allows us to then define the inputs that are needed for the AI. So it needs to know what's its target. So we set the target here. Then we can set a wander delay. So how long, or how often do we want the character to change its movements back and forth? We also have this pursue distance. So how far away can the target be before we say that the target's in range to start pursuing? And then what the cooldown period is for an attack. So that's the attack timeout. And so in here we just initialize the different behaviors. So like I said in that graph that we drew, we want to start out in the wander state. So when we begin the wander state. We then set the next move. And so I haven't really talked about this time.time. So the time class within Unity, so this allows for accessing the time measurement that Unity is providing. So Unity is keeping an internal clock to tell you how long it's been running, how long, say, the last frame took to run. If you have a set or a kind of fixed update rate, kind of what that fixed update rate is. So time.time just says this is the current time that the engine knows about. And so for our next move, we can say we want the next move to happen at whatever the current time is plus our wander delay. And then for the next attack, we can just say if you're in range, say the time is now, so it doesn't add on that cooldown. So we come down into the update. So this is where we're gonna construct our state machine. And so the way we're doing it, so a switch statement, you can think of a switch as a set of nested if-else statements. And so you probably have a little bit of experience with this. So you could say if a certain condition is met, and then have code that runs if that statement's true. And then you can say else, and then have another conditional associated with that. So you have if, and then else if, and you keep doing that, so on and so forth. So else if, else if, else if. And so what a switch statement does is kind of compacts that. So we're just interested in looking at one particular condition, which in this case is what is the behavior state at any time. And then we can see if the behavior state is set equal to wander or pursue or attack, then we want to do something in each of those states. So for instance, in wander, we're going to call the wander behavior, and then we're going to do our transition check to see if we need to transition to the pursue state. And likewise, if you look through the rest of this, so we have pursue, and it follows the same pattern. So you call the behavior, and then you do the check for the transition. Likewise for the attack, you can do perform the attack behavior. In this case, I said pursue. So we can change it to wander. But if we want to, we can just have it go immediately back to pursue. It's kind of up to you what you want to do. Then here we call move. So where does this move come from? And so move, if you remember, I said this extends the character controller class. So this just goes back to our character controller that just calls the move within character controller. So we don't have to rewrite any of the logic for how to move the character around. We've already done that within the move. It's just a matter of determining when to move the character, and so in our case, which direction it's going to move and if it's going to jump. But the code to actually move the character and get the jump, we're already handling that, so we don't have to re-implement that at all. And so the rest of the code base, this is handling all the behavior code. So all the behavior code is written for you. So in this case, here's the handle of wander. And so in this case, if the time exceeds the next move, then we change direction and we set the next move to some time in the future, and randomizing between our wander, the value 1 and our wander delay. Likewise, pursue. What we're doing here is just seeing which direction that the character needs to go in order to chase the player. Then attack is just saying to just updating the cooldown and then saying go ahead and attack. And here detecting the target, we're just looking at the distance from the target to the enemy, and if it's less than the pursue distance, then we say let's go ahead and say it's been detected, and otherwise false. And then the last one, the can attack. So in this case, it's seeing if the cooldown period has been met, and if so, goes ahead and signals to say you can go ahead and attack. So really what we're going to do is take these different behaviors and then also take those different those different checks and put them into place to then construct our state machine. So let's go ahead and kind of fill out the state machine. I'm going to squat. Sorry, I'm type. Okay. So in this case, so here for wander, it says to call the wander behavior. And so if you remember our wander behavior, it takes no parameters and it returns a float. So if we come up here, so our wander is tied to the character moving from side to side. And so that corresponds to this move variable, because that tells us the direction the character is going to move. Either if it's a positive 1, it goes to the right. If it's a negative 1, the character goes to the left. So here we can say move equal to wander. So that will then give us what we need to set for the move. And then we do and then here we have to do the transition check. So if we can see the player, then we need to change the pursue state. And so to see the player, that's this detect target. So detect target is going to return true if we can see the player and false if we cannot. And so here I'm going to say if detect target. So if this is true, then we want to transition to the pursue state. And so we're using this mBehavior state to say what our current state is. And so now we're going to update our current state to go from wander to pursue. And that's it. And so that handles the wander. So likewise, we can go into pursue and do something similar. So again, with pursue, we're just really trying to figure out which direction the character needs to go in order to chase the player. So if they have to go to the left or to the right. So again, we're just calling move, and we can set pursue to that, and then that should handle it. And then when you do, so here, if you come back to our state machine, so there's two transitions here. So one transition is if we no longer can see the player, then we want to go back to the wander. And the other one is that if we can attack, or we're past the cooldown period, let's go ahead and move into attack. So in here, it's just doing so if our attack cooldown is elapsed, so let's change the attack state. So here we say if we can attack, then our behavior state is going to be set to attack. And move this. Move this up here. So in this case, oops. So here I just want to say if we're out of range, then we want to change to the wander. So we've already used this once. So for detect target, if this was true, then we say we want to pursue. And now we're interested to know when this is false. So when we can't detect the target, now we want to go into the wander state. So here, let's say detect target. And then if you remember, we use that exclamation point to negate the result. So in here, if detect target becomes false, then we negate it to make it true, so then this code will be accessed. And so here you can say behavior state, and then we want this to be the pursue state. And then on a, whoops, I don't want to do that. Just want to line that up so it looks a little bit prettier. Okay. And then last but not least is the attack. And so like I said, the attack for our character is just going to be a jump. So we just want our little blob characters to kind of jump up in the air, come back down on the player. So, so in this case, instead of manipulating the move, we want to manipulate the jump. So here we want jump set equal to our attack method. And then we do this transition, and here we're not really doing a check, we're just saying you're going to attack and then transition immediately to another state. And so I said wander, and like I said, it could be wander, it could be pursue. It's really kind of a matter of kind of preference, which kind of how you want what you want the enemy to do. For now, just to keep it in line with that diagram I put together. So I'll just leave it at wander. So cool. So that like I said, so that handle is kind of putting together our state machine. And so now, whoops.
Wait, why are the notes just like just 2 slides?
So, it's just because it was just to show just that MEA.
Oh, okay.
So it looks like everything compiled all right. Those are just some erroneous messages. Okay, so now we have to actually go through the process of putting together an MEAI character. And so it's because we're using that character controller, much of what you did in order to get your main character to work, you're going to have to replicate for your enemy character. And so this goes into all the details that we talked about in the other when we got into the character. So I'm just going to go ahead and I'm going to make an empty object, and I'm going to just call this blobby. And so what were all the components that we added onto our player character? What?
Rigid body?
Yep, so we had a rigid body. So that's in order to get the character to actually move or respond to physics. The other thing we want to do too is remember to freeze the rotation on the Z. So what were some of the other components that we had?
Sprite renderer.
Sprite renderer, yep. So sprite renderer. And for now, I'm going to add, whoops, that's a big slide. So this is also added into your the Unity 6 package is a slime character. So if you don't want to make your own animal, you can use this one. But one thing I need to do, if you remember, with any sprite sheet, we have to go through and chop it up into separate images, because we're actually going to animate the slide using those 3 images there. So if you remember, just to recap how to do that, if you just come into multiple, and then here we're just going to slice it let's see, if I were to slice it automatically, it looks reasonably close. So I'm just going to leave it as that. I think that there's it's like 1 or 2 pixels off from each one being perfectly, but that's fine. So let's just go ahead. Or is that? No, I don't think that's the case. Anyway, this should work for our purposes. So I'm going to come back to our blob. Okay, so it did set to slime 0, but we have to get it set up so it is existing kind of in the foreground. And we'll just leave it in this kind of jumbo fashion for now. So what are some of the other components? Yep. Yep. So the collider. So it seemed like we had the most success with the capsule collider, so it can roll across the different tiles. So we can put that there, and then also, like Danae was saying, we need a ground check, because if you remember from our other character, we have this ground check to determine if the character's on the ground, just so the character controller didn't know if we can jump in there. And so, like I said, because we are modeling, we're extending character controller, we have to do kind of the same thing here. So, and again, you also have to name it the exact same way. So I'm gonna say create empty, say ground check, and then so we want to make sure that it's kind of sitting below the character. So we'll put it right there. Okay. Is there anything else that we're missing from our components?
You could do the animator too.
Yes. So let's do pointers. So we have to have an animator, and then you said if you wanted to. And with the character controller, if we look at the character controller, so within the character controller, we're making these calls to an animator, and we're also making calls to try to manipulate specific parameters. So not only we actually do need it, and we also need it to replicate the same parameters that we already have with the character controller. With the animator that we have from our player. So, okay, so let's go ahead and add an animator. At this point, some of you may be a little distressed. You're like, oh, dude, I don't want to rewrite this entire animator all over again. And so I'm here to tell you that you don't have to. Because really what we can do is we can just copy what we have here. And then we just have another animator that just is what we already have for our main character. And so if you do, if you're on Windows, you do Control D. You'll duplicate an asset that you already have. And then for our Mac users, it's Control Option key. And that will it will just make a copy of whatever asset you have highlighted. And so in this case, I'm going to rename this. So it's just called enemy. Whoop. So we can get that to work. Says, oh, that already exists. Okay, I was probably screwing around with something earlier. I'll just call it slime. How about that? So if I were to open this up, so you can see, it keeps everything that we've already created previously with the states and transitions. And it also has, all the parameters already set for us. So everything's there. What we have to change, though, are the animations that get played. Because if we leave it as is right now, these animations, so the animator already has the animations you've already put together previously. And so these animations are tied to your main character. So we need to make an animation for our slime and then replace the slime animation within the different states. And so, I said, if you don't want to do a slime, you want to have your own enemy. Once it goes, have to make animations for your enemy. And likewise, too, you don't have to follow this animator. You don't have to follow, you really want to follow the same kind of style for the animator. If you want to modify the animator to get it to better fit how you want your enemy to move and how it would appear, you definitely want to do that. I said, this is really just to kind of repurpose a lot of work that we've already done. So just be able to kind of quickly put together an enemy. So let's see. So what I want to do now is I want to construct an animation for this slime character. So I'm going to come in here, open up the animation, say create. We're just going to call this swaying blob. That sounds cool. Okay, so I'm already highlighted on the blob. I'm going to go ahead and just parent this here and bring up the scene. And then I'm just going to just do the record. So if I start here, I need to add this right here. Sprites. So I'm going to move this keyframe. So change that keyframe to that slime, and then add another keyframe, and make it that slime. So now it's good. So I'm going to scale a little bit. So that's pretty cool. So we'll leave it at like that. Okay, so now I can come back to the animator, and because I tried to create an animator for Blobby. I really don't need that one, so we can delete that. But for our slime, so I'm just going to replace all of our animations with just the swaying blob. Okay. So that handle. So we still need to add that as a controller.
Oh, so that's one block as part of the package.
The sprite is.
Okay.
So this is in the package. You would have to create the animation to go with it.
Okay.
So the last thing we need to add is our AI controller. And so AI controller, you can see it has all of the same, it has the same parameters as character controller, so max speed, jump force, this air control, what is ground, run multiplier, maximum jumps. And then the parameters that are specific to the AI controller appear at the bottom. So picking the target, setting the line delay, pursuit distance, attack timeout, all those. So let's go ahead. So I'm just going to make, I want my blob to kind of move a little slow. So we'll set it at 5 and just make it kind of jump. It's pretty low. In this case, we want, again, we can specify the ground. One multiplier, maximum jump count, these don't really matter because we're not. If you wanted to, you could tap into, because you've already programmed this to handle how to do a run, if you've done this already for run multipliers or double jumps, you can actually get your AI character to do this as well. Yes, Christian?
So if you were to have two different types of enemies, if that one would have to change, you just put in the same AI controller and change those parameters to make them different, so it's almost like more insistent on pursuing you or whatever.
Mm-hmm.
Okay.
Yeah, so you can, so we're still kind of limited into what the behaviors that we provide for our state machine. So right now, you can modify the pursuit distance. So one is more eager to chase after a player than another one. Likewise, you can also make it where if you want their attacks to happen more frequently, you can change the timeout to longer if you want a longer delay for the attack. So yes, really you can set up different types and then modify these parameters to kind of satisfy how you want the enemy's behavior. And then, like I said, if you want behaviors that are kind of radically different and depart from states you need to define at that point, then you have to add in new states or modify the state machine in order to do that. So let's see. So the last piece is here. So for the target, we want the player to be the target. So for right now, so wander delay. These are just kind of arbitrary. Like that. If you want to change the values, whatever you want, you can put those in. So I'm going to move the enemy over here to try this out. So let's play and kind of see what this looks like to begin with. Whoops. Let's try that again. Okay. So it's kind of hard to see. If I go find our poor little enemy's stuck in the hole. So let's fix it. So we can fix that. So let's make its wander delay shorter. Let's see if that helps fix. Whoa. So for a big guy, it runs pretty fast. So So, like I say, so you can sit here and kind of and muck with these. So one thing would be I could change the max speed, so I can make that max speed go lower. Another thing we could do too, so because it is kind of a big old blob, we can also increase the mass. And so by increasing the mass, it makes it harder for the character. It takes more force in order for the character to move. And so, say if we upped it by 2, you can see what that looks like. It's still getting around pretty quick. So let me change that. Let me change its max speed to 1. There you go. Now it's just bopping along. So if I open up the debug, so here, because I open up the debug, you can see that paper state. You can see it in the water. So right now it's like a water. So you should see it change as we, as the character moves and the AI perceives something new. It changes from and transitions to different states. So I'm going to go ahead, start. So right now it's set to water. So that's in pursue. That thing is chubby. So right now it's just going to be stuck on pursue. And because it can't fall, because it's stuck in the air, it's not going to be able to jump. So poor chunkster. I think what we'll do, shrink him a bit, so he can move around a little bit better, a little bit slimmer. So let's try that again. So you can see, just kind of filling a hole. So you can see it is jumping. It's just it's trying to bump up against that. So, not having much success. But like I say, you can see the character kind of moving around and doing his attacks. So let's see. So there's some other things you need to note in here. So if you remember our checkpoint, so we have this checkpoint that we created. And the way that we handle the checkpoints is that when something entered the trigger zone for the checkpoint, we would then flag it as true. And then last we flag as false. And the idea being that as the player went across the level, it would then hit these checkpoints and if the player died, it would just respawn the last checkpoint. So can you see a potential problem that we have now with our AI character?
Will it trigger the checkpoints?
Yes, it will. So, because now we have another object in here that's moving around, it can trigger those checkpoints. So we have to modify how we handle the detection of the checkpoints to ensure that we only set that flag whenever it's the player that enters it, not the enemy. So we've done, I guess, kind of other ways to verify whether or not what we're colliding with is the player. So if you remember, if I bring up like our destroyable script. Oh, actually, I have to destroy it. I meant the pickup script. So if you remember in our pickup script, we would look to see whatever we were applying with had to, if it had inventory manager component, then we would assume, it's client player. So let's go ahead and do everything for that. And so you can do something like that, but it's for what we want to achieve with the checkpoint, it's not that intuitive. It's kind of all clunky. So kind of another feature that Unity offers that we haven't talked about. So we talked about this idea of layers, right? So the idea behind layers is that we can organize groups of objects and say and have them fall into a certain quote-unquote layer. We also have this another method of kind of classification called tags. And tags are pretty much the same thing as layers. So what a tag allows you to do is to go through a pit, so you can assign tags to objects like you would layers. And so the difference being is that the tag is saying that it's just a string, whereas the layer it has a layer mask associated with it, which is a different variable type. So in this case, you can come in and you can add, and you can make your own tags too. So if you say add tag, so I got ahead of myself here. I put in one for enemy, but you can come in here. I said you can set wherever you want. I'll just go ahead and have an enemy tag. By default, it comes with a player tag. So you can set your main character to say the player tag, and you want to set your enemies that enemy tag. And we'll show how to use that, especially when we get to when we have the player colliding with the enemy. So I want the player to take damage. That ends up being a useful way to determine if the player is colliding with the enemy. So anyway, so let's go ahead and if I bring up the checkpoint code. So this is the way the checkpoint code works right now. It's just as soon as something enters the trigger, we set that variable to true. And likewise, if something leaves it, we set it to false. So now we want this to be we want this to only happen when it's the player. So in this case, we can say if. In this case, we want to look at what we're colliding with. So other game object. And there's this tag. And we see that equals. Oops. And you have to make sure it's case sensitive. Or the cases match. So player. So we can do the same thing. Okay. Okay. So now, like I said, if and we can test. Excuse me. Test this. So I'm gonna move. Whoop! I don't want to move a tree. I want to move this enemy. So I'm gonna put this enemy closer to the player.
Well, I get like a maze or everything where you have to run past the. You might want to put something there to block the enemy from falling off.
You can do that, or you can have it where that's a strategy.
Classic. And then jump.
So,
That is so classic.
so right now, I come back, so I look at the checkpoint here, you can see the checkpoint has been triggered, because I was surfing the block, it didn't collide with it was the block that collided with the checkpoint, not the player. So we'll change that, because we want the player to take damage when it touches the enemy. So we'll probably save that, not at least on our next class, so we get into that. Anyway, I think, yeah, this may be a good time to stop, because I said we can get into, because really kind of the next part that covers the remainder of the assignment is the player damage and tying that damage into the health bar for the character. So we'll save that for next time. Like I said, I think this should be more than enough to get started. It's like putting together a state machine, and starting to put together an AI character, and kind of messing around with it. If you have questions on how to mod this, so if you want a different set of behaviors than usually what the state machine currently provides, just send me just ask me by email, or just just talk with me. I can show you. That's going to kind of modify the state machine that we already have. If you want to kind of do something a little bit different than kind of what's been outlined already. But yeah, so I think we'll call class today. That's it. There's no class next week. So this will give you plenty of time to kind of play around with this, and then we'll resume this, I guess, on the 13th. Yeah, 13th. Alright, so, okay. Like I said, and just make sure you get your assignment 5.